Okay, so this is problem 5.9.15, and they give us this problem. A scientist wants to research the spread of germs, and she knows the possible number of handshakes within a group of n people is given by capital N equaling 1/2 n squared minus n, and then everyone at a party shakes hands. There were 190 handshakes in all. How many people attended the party? Okay, so the first thing that we want to be able to identify is that lowercase n here and capital N are different variables, okay? And this lowercase n is referring to the number of people, and they don't actually state it in the problem, but they do state it in the textbook. They give a few examples of this, that capital N is referring to the number of handshakes, okay? So they're giving us a number of handshakes here. They're giving us 190, so we want to actually take that 190 and plug it in for the capital N, and then this will be the problem that we're solving. Okay, so it's 190 equals 1/2 times this n squared minus n. Okay, so if we want to solve this, first thing we're going to want to do is take this 1/2 and distribute it. So it's going to look like 190 equaling 1/2 n squared, and then minus 1/2 n. Okay, and I would probably want to clear the fraction here, just make it easier to work with. So I'm going to multiply both sides by 2. That's the common denominator in the problem. And if we multiply by 2, that'll end up clearing the fraction. So 2 times this 190 here gives us 380. And then 2 times the half gives us 1 n squared. And then 2 times the half here gives us 1 n. Okay? So remember that when you multiply fractions, you multiply straight across. So if we take 2 times a half, you're just multiplying 2 times 1 on the top, you get 2, 1 times 2 on the bottom, you get 2, and 2 over 2 reduces to be 1. So that's where I'm getting these coefficients of 1 right here. Okay. Alright, now this is in quadratic form. We have something squared minus something else to that first power, and then we have a constant over here. So what we want to do is we want to set this to 0 so that we can solve it. So let's subtract 380 from both sides. And running out of room. And so let's move to the next page. I'm going to have to fix the autofocus on this thing. We have to put up with it just for this video. So, okay, so, oops, no. So we subtracted 380. So we have 0 now on this side. And n squared minus n, and then minus 380. Okay? Alright, and what we want to do now is factor. And I'm just going to use trial and error. And I'm going to use n and n, and with the 380 I'm going to use 20 and 19. You can play around with that number on your calculator and try and find the different factors, but I just recognize that 20 times 19 is going to give me 380. So if you look at the outside here, this is 20n. If you look at the inside, this is 19n. And if we want to get a negative 1n, then our 20 should be negative and our 19 should be positive. Okay? So if we check that, we need to check and make sure that the last portion of FOIL works here. So positive 19 times negative 20 is a negative 380, so that works. Okay, so this is our factorization, n plus 19 times n minus 20. Okay, and we do want to solve, so we're going to set each piece to 0. That's using the zero product rule. And we're just solving, so I'm going to subtract 19. So n equals negative 19, and then over here when I add 20, this is n equals 20. Okay, now we need to go back and take a look at our problem because we are working with a word problem. So we need to see if both of these answers are going to make sense or just one of them. If you take a look at what it says, it defines little n to be the number of people. And so we're talking about the number of people